Hi everyone, thank you for watching this video. In this video, I will introduce my final project for course Intermediate Python Programming. My project aims at designing a website hyperlink network analysis toolkit for general data analysis usage. At the very beginning, I just want to conduct some hyperlink network analysis to investigate the evolution of the structure of some short-term rental platform in recent years. However, as the project grew larger, the structure of the whole data analysis program became really hard to organize. In this case, I came up with an idea to reformat the whole project to a well-organized and generalizable data analysis package. By doing so, I can ensure my data analysis results can be easily examined by others, and the tool I developed in this project can also be used to analyze other websites in the foreseeing future. Well, now, let's take a look at the tools I developed in my toolbox. Actually, in my toolbox, I have mainly 6 sections, and it provides us some very useful tools to analyze a hyperlink network of website. So the first one is Hyperlink Network Crawler. The web crawler is based on Wayback Machine. The web crawler is based on Wayback Machine, a web archive that preserving history snapshots of web pages on the internet. Based on it, I am able to acquire historical version of the website I want to analyze and most frequently visited child pages linked to it. The data scraping strategy employed in my case is called snowball sampling, which enables me to achieve the largest dataset, that is the maximum connection subset of the network. I target the root pages of the platforms and then searched for the web pages that can be directly reached from these root pages, putting their URL to a stack. After that, I repeat the whole process for each page in the stack. In the end, theoretically, I am able to get all the links in the archived by the Wayback Machine in the focal platform. This is a type of breadth-first search method. The class of the web crawler is called historic web crawler. It needs to be initialized by setting target website, start crawling timestamp, and end crawling timestamp. When using it, we also need to construct a filter function to customize the stop crawling condition for the crawler. The stop crawling logic should be different for each website, since the structure of the hyperlink for each website is definitely very different. Here I use Airbnb as an example. I don't want to get specific web pages for each host and their listings. In this case, if there are slides in the hyperlink that contains prefix like /rooms, /users, /tribals, the crawling process stopped and I just jumped to the next link in the stack. After getting raw hyperlink each table, I need to format it to a more friendly form. So I designed a hyperlink network object to store hyperlink network information to benefit future usage. In my example, I obtained the yearly hyperlink network of Airbnb.com from 2010 to 2020. This is how to load them as hyperlink net object. The hyperlink net object has some attributes and the internal method for user to visually observe the data. Data returns data frame. The data attribute returns data frame that stores each table of the hyperlink network. Nodes returns list contains all nodes in the hyperlink network. Graph just returns the network X object storing the hyperlink net as a graph. Besides, I also have getMatrix method that is used to transcribing the data into matrix format. GetLayers reports all the nodes in the hyperlink network and their corresponding level. Also, I have get summary. It simply presents a summary table for the degree, in degree, out degree of the links. The third section is hyperlink network visualization. I designed mainly two ways to visualize hyperlink net. One is using network and the other is using heatmap. Besides, I also constructed some method to visualize analysis results. I will introduce two network visualization methods in this section and present other visualization at the analysis and the prediction sections. The first method is called plot as network. There are numbers of parameters to customize the appearance of the network. Because each of the hyperlink network is very large, containing thousands of nodes, running the method is somewhat time-consuming. Hence, I present an example of using this method to visualize hyperlink network of Airbnb in 2010. A more efficient alternative method to visualize a hyperlink network is plot as heatmap. This method can also be used for network comparison purposes. Also, we can determine how many nodes we want to visualize. In this case, I set subset to 500. The method will select the most important 500 nodes appearing in all of the inputted hyperlink nets and visualize them as heatmap. We can clearly observe that some minor changes happened in the hyperlink net structures over these years. There is another method called plot multi-distribution. It helps us to plot the distribution of degree at each layer of the hyperlink network. The fourth section is single hyperlink network analysis. To conduct advanced network analysis, I just built some single network analysis method first. I don't plan to introduce all of this method here because of the necessary background knowledge of network theory. It's very difficult to explain and in the time frame. So here I just present some examples on how to use this method. I'll use find mean structure in the method analysis section as an example. This method uses a self-designed algorithm to detect the mean tree-like structure of the hyperlink network of the website. The fifth section is multiple hyperlink network analysis. Building on the single network analysis method, I am able to implement more complicated cross-network dynamic analysis at different levels. First, for micro level analysis, this toolkit provides users with methods to compare nodes across networks via different metrics, identify the changing of the role of specific nodes in the network, and visualize evolution of specific nodes in the website over time. For method analysis, there are methods to presenting the changing of the mean structure of the website, computing the small cluster complexity over time, and extracting the mean subgraph of the hyperlink network in each timestamp. Also, I have a method to visualize how complexity of the hyperlink network changes with time. Finally, for micro-level dynamic analysis, there are methods to compare the similarity between two networks, calculate the changing of the size of the network at each layer, measure the evolution of the whole hyperlink network over time. In the end, based on all the metrics generated in the analysis process, this toolkit provides methods for us to perform prediction tasks to forecast the dynamic of nodes, clusters, even the whole website hyperlink network. I packaged numbers of different models to do the prediction. In this example, I want to predict the change of the average clustering coefficient of the hyperlink network of Airbnb. To achieve so, it's necessary to calculate it and some supplementary predictors first. After that, we need to initialize the hyperlink net prediction class, specifically designed for hyperlink net prediction. The first and the simplest model is linear regression. We can set how many steps we want to predict to parameter forward. After fitting, the model will output a summary, the prediction results. The prediction results here, and prediction visualization sequentially. For advanced time series forecasting, it is necessary to firstly test whether the series is stationary or not. A default test method presents that my current predicting series is stationary. I tested the performance of autoregressive model, a moving average model, a Riemann model, and a VAR model at the prediction task. The output of each of these models is in a similar format, enable users to easily make cross-model comparison. Note that the prediction does return the fitted model for users. In this case, users can actually implement further analysis or experiment based on these fitted models. So far, I have introduced the most important part of my final Python programming project to you. Hope you liked it.